So in this video here, we're going to continue where we left off, which was in level 2, problem 15. So in these problems here, we're asked to determine the two coterminal angles, and they're given in either radians or degrees. So here are degrees and here's our radians. And one of them needs to be in positive. One of them needs to be a positive angle and the other needs to be a negative angle. So let's just review for a moment. If you want a coterminal angle, what that means is coterminal angles have the same initial side and terminal side. So you can have different value angles, but sometimes they can hit in the exact same spot or the exact same location on a graph. So in this case, the way we can figure out a coterminal angle is to go one revolution around. Or in other words, we can add by 360, that's one full circle, or that's also equivalent to adding by 2 pi, which is in radians. Or you can subtract by 360, or subtract by 2 pi. So starting with 15 here, we have 325. We need to find a positive coterminal angle. So what I could do is start by adding by 360, because that would just keep it positive if I add. So I'm going to take 300, let me not use red, 325, add 360. And so that would give me, let's see if I grab my calculator out, 685 degrees. So here is basically a coterminal angle for 325. It means that if I were to graph this value, it would hit in the exact same location as 325. Now let's find a negative one here. So I can also take the 325 and subtract 360 to find a negative coterminal angle. So 325 minus 360 is negative 35, and it's a negative valued angle. So now I have a positive coterminal angle and a negative. Now I could have subtracted more 300 and, if this wasn't negative, I could keep subtracting by 360 until I make it negative. Or if this wasn't positive, I can keep adding 360 until it became positive. So 16 is a great example to show you that. So this is negative 400. So first off, I'm going to take the negative 400 and I'm going to add 360 to try to make it positive. By the way, sometimes I write degree sign and sometimes I forget to. It doesn't really matter as long as the answer has a degree sign. So if I take negative 400 and add it with 360, that gives me negative 40 degrees. But that's not a positive degree, that's a negative degree. So this will count as my negative angle. So I'm going to do this again and keep adding. Oh, sorry, not keep adding. So I'm going to take the negative 40 degrees, this negative 40, and add another 360 so I can find a positive angle. So if I take negative 40 and add positive 360, I get 320 degrees. And so now I have a coterminal angle that is a negative and a coterminal angle that's positive. So notice that I didn't do the exact same step as this side, and that's okay. The idea is that you're either adding by 360 or you're subtracting to get a negative angle or a positive angle. All right, let's try radians here. So this is 2 pi over 3. And so if I'm using radians, I need to add by 2 pi's. So let's go ahead and do that. I have 2 pi over 3, and I'm going to add by a positive 2 pi. Now to add with a fraction, I'm going to put this over 1 to make it a little bit easier. And then I'm going to try to make a common denominator. So if I multiply by positive 3, I can do that. I might run out of room, but that's okay. I'll try to make some more room. So this would give me 2, I'm just going to carry over the 2 pi over 3 and add that with, that would be 6 pi over 3, right? Because 2 times 3 is 6, and then bring the pi over. And so if I add these two numbers here, I get 8 pi over 3, and that's a positive angle. So that's my first positive angle. I need a negative angle, so I'm going to take that 2 pi over 3 and subtract by 2 pi. So I'm going to put that over 1. And then try to get a common denominator, so doing the same thing. So I have 2 pi over 3 subtracted by 6 pi over 3. And so this would give me, let's see, 2 minus 6 is negative 4 pi over 3. And so that there is my answer. I have one positive coterminal angle and a negative. All right, let's get into 18 here. So for 18, I have a negative pi over 6. So I'm going to take negative pi over 6 and add it with 2 pi to make it positive. So again, I'm going to have to put this over 1 so I can add it with this fraction, get a common denominator. So this 1 can be a 6 if I multiply top and bottom by 6. And so that would give me negative pi over 6 plus 12 pi over 6. If I add, I get 11 pi because that's negative 1 plus 12. So that makes a positive 11 and 6 on the bottom. And so I have 11 pi over 6. This is a positive angle, so I'm good with using this guy. Now I'm going to try to get a negative angle. So again, I'm going to take that negative pi over 6 and subtract it with 2 pi to make it a negative. So I'm going to put this over 1, multiply it by 6 to get a common denominator. So that gives me negative pi over 6 if I just carry this guy over. And then this here, negative 2 times 6 is negative 12 pi over 6. If I subtract these two, that's negative pi minus 12. So negative 1 minus 12 is negative 13 over 6. And so from here, these two, this one's a positive, this one's a negative angle, so I'm good to go. All right, and that's it for our coterminal angles. So for our next part here, we're going to be talking about properties of a 30, 60, 90 triangle and a 45, 45, 90 triangle. So for a 30, 60, 90 triangle, and these properties only work for a right triangle. Generally, the 60 degrees is the side that is holding the smaller, the shorter side. So the 60 degree versus the 30 degree, that would be here. The bigger the angle, usually the shorter the side length. So this here is a little bit shorter. But when you compare to the hypotenuse, and the hypotenuse is always diagonal from the right angle, it's going to be double the amount. So if this side here, let's call this side here a length of x, that means the hypotenuse is twice the amount, so 2 times x. And then this side here, which is the other leg of the right triangle, is going to be x times the square root of 3. And that's how you can find all the side. It's just remember that the shorter side is half of the longer side. Or the longer side, the hypotenuse, is double the amount of the shorter side. Let's take a look at 45, 45, 90 triangles. Let me do a better job doing this one. So if this is a 45, 45, 90 triangle, that means both sides have the same degree. They're both 45s. In that case, that means that if both sides have the same angle, both sides are the same length. So this length is the same as that length, so they're both x's. And then the hypotenuse here is going to be x times the square root of 2. And then that is it. So hopefully that helps you identify which side is which. So in this case, if you know it's a 45-degree angle, that means both sides are equivalent, and the hypotenuse needs to be whatever that value is times square root of 2. All right, let's move on to our next problem here. So number 20, it's asking us that we are given a triangle, a right triangle. We need to find the missing indicated variables. So looks like we have some variables here. and the missing angle. So I'm going to start with the missing angles because it looks like each one of them has already 2 angles given. So that makes it a lot easier because I know a full triangle makes 180. So if this is 90 and this is 30, that means this side here has to be 60 degrees. Because 30 plus 60 is 90 degrees. Add another 90, that's 180. Next part here is I need to figure out what x is and what's y. Because I noticed that this here is a 30-60, I can use this property here, which says that if you know the hypotenuse, so the hypotenuse here is 10, well, that means that x here is going to be half of the hypotenuse. So if you were to think about it mathematically, half of 10 is 5. If you struggle to do this, another way you could do it is take the 10 and set it equal to 2x. So 10 equals 2x, and then you'll divide by 2, and x is equal to 5. And so that there, this x is equal to 5. All right, next is we need to figure out what is the length of y. To figure that part out, let's look at the properties here. So this is the longer side with 30. So for 30, this it's going to be x equals square root of 3. Well, I already know what x is. So let's just write down what the template says. So y is equal to x square root of 3. We actually already know what x is. X is 5 square root of 3. And so in this case here, my y value is equal to 5 square root of 3. All right, so let's try out 21 here. So for 21, we have a right triangle again. This side is 45. This side is 90. So if I take, 180, subtract 90, that's 90. Subtract a 45, that means I have 45. So this angle here has to be 45 degrees. And most people notice, like, if this side here is 45, then this side must be 45. And you have what we call an isosceles triangle. So that means both of these legs here are the same value. So if this side is 7, that means this side, or this x value here, also has to be 7 because both of the angles are 45. So the lengths need to be the same. But the hypotenuse doesn't have to be the same length as the legs. So the hypotenuse is determined by knowing what x is. So our x here is 7. Notice to figure out the hypotenuse is x times square root of 2. So this is going to be x square root of 2. Our x here is 7 square root of 2. So that means that there is our hypotenuse length, or our r. And that's it. Okay, so that was level 3. Let's talk about level 4, last level here. And it's over the trig ratios. And so that one there is quite hefty. It might be helpful to have all 6 trig ratios in case you have forgotten about them. So for the trig ratio, we have sine, cosine, tangent, which is the 3 original ones. So sine, if you remember SOHCAHTOA, so means sine opposite over hypotenuse. So this would be, so here's the sine opposite over hypotenuse. Cosine is ca, or a, which is adjacent over hypotenuse. And then our last one here is tangent. So tangent, or TOA, is opposite over hypotenuse. So I'm going to put opposite first here, and then adjacent. All right, so now we're going to get into the reciprocal identity. So this one here is cosecant, this one's secant, and cotangent. And so these here are reciprocal. So I'll write here reciprocal, which means that the fraction here is flipped. So this would be like the hypotenuse over the opposite for cosecant. For secant, you have the hypotenuse over adjacent. And then for cotangent, you have adjacent over hypotenuse. Or sorry, not hypotenuse, opposite. All right, so now when we're looking at this, we have our full set of our trig ratio. So let's get started with 23 here. I'm going to shrink this down just a little bit. So when you look at 23, you're given a trig ratio of cosine for 4 over 7. And you're asked to figure out what is the other 5 trig ratios. So we're missing right now sine. We have cosine. We don't have tangent. We're missing cosecant. We're missing all the trig inverse. So when I'm looking at sine here, oops, I didn't mean to draw on that. So I'm looking at sine. Sine is going to be opposite over hypotenuse. But all I'm given is 4 over 7 for cosine. So what I have to do is build a triangle. So I'll put my angle here. So this is going to be 7, or in this case, this here is the hypotenuse, which is going to be 7. And then 4 here is the adjacent side, so that's going to be 4 right here. And what we need to do is figure out these trig values, so we need all 3 sides of the triangle. So if this is 4, I'll call this side x. We have 4 squared. I'm going to use the Pythagorean theorem. So 4 squared plus x squared minus 7 squared. And so that would give me 16 plus x squared equals 49. If I were to subtract off 16, this would leave me with, let's see, 33. 49 minus 16 is 33. And so I have to take the square root of that on both sides. Now, since it's a triangle, I'm just going to care about the positive root. So this is going to give me x is equal to the square root of 33. And I can't reduce, can't take the square root of 33, so I'll just leave it as a square root. So now that I know all 3 sides, I can try to complete all 5 trig ratios. Like sine here, sine is opposite. So we look over here, sine is opposite over hypotenuse. So that means that this here will be opposite of this angle is the square root of 33, and then my hypotenuse here is 7. And I can't reduce this, so I'll just let it be. And then my tangent here is opposite, so it's opposite over adjacent. That is going to be the square root of 33 over 4. That's the adjacent. Okay, and then from here, let's talk about the reciprocal trig identity. So for cosecant, it is the reciprocal of sine, as you can see here. So in that case, we're going to take the sine and flip it. So we would have 7 on top and the sine here, the square root of 33 in the denominator. But what we learned is we can't have roots in the denominator because it's really hard to divide by a root. So we try to get rid of it by multiplying by the same root on the top and bottom. If you're multiplying the same number on the top and bottom, it won't affect the actual value since you did it to the numerator and the denominator. So in this case here, if I take 7 and multiply by square root of 3, I just get 7 square root of 33. But the bottom here, since they're both the same root, the roots cancel, so this becomes 33. And so we have 7 over 33 can't reduce, so this is it. Let me box in my answers that are completed. And then for secant, it is the reciprocal to cosine. So my cosine here is 4 over 7. So this is secant is going to be 7 over 4. And that I can't reduce, so I'll just leave that there. And then cotangent is going to be the opposite of tangent. So this is going to be 4 over square root of 3. Or sorry, square root of 33. And so that means I have a square root in the denominator. I'm going to multiply the top and bottom by a square root of 33 to try to get rid of it. And so then the bottom here is just going to end up being 33 because those square roots will cancel again. I can't reduce 4 and 33, so I'll leave the answer like this. And that is it. Okay, so let's get into 24 here, our last problem. So very similar as to before, but just a little bit different. You have a cotangent, so you have a reciprocal trig function. And we have to find the other 5. So again, I need to start by building a triangle. So a right triangle, I'm going to put the angle right here, and then I'm going to fill out the sides of the triangle. To do that, you're going to need to figure out what is your trig ratio. So my trig ratio is cotangent, and this is a 3 here. So cotangent is, let's take a look. It's adjacent over hypotenuse. So that means that, let's write that here, adjacent over hypotenuse, or opposite. I always say hypotenuse instead of opposite, my bad. So my cotangent is adjacent over opposite. Notice how this is written as a fraction, but this 3 is not. So what we do is we force it to be a fraction by putting the 3 over 1. All right, so doing this allows me to identify that the adjacent side here is 3. So from this angle, this side here is 3. The opposite side, so right here, is 1. And now all I have to do is figure out this hypotenuse side by using the Pythagorean theorem. So we have the 2 legs, so I'm going to take 3 and square it, and take the 1 and square it. And then I'm going to find the hypotenuse. Let's just call this x here. And so that would give me 9 plus 1, 3 squared, plus 1 squared is going to end up giving me, oh, this should be squared when we're using the hypotenuse for the Pythagorean theorem. So 9 plus 1 is going to give me 10. If I want to find what x is, or this hypotenuse, I'm just going to take the square root of it on both sides. So that cancels. So x is equal to the square root of 10. So that means the hypotenuse here is the square root of 10. And so we're ready to go. We're going to find our missing trig function. So we don't have sine, we don't have cosine, we don't have tangent, we don't have cosecant, and we don't have secant. So all we have is cotangent. So that's why I don't have cotangent down here. So for sine, we need opposite over hypotenuse. So if you remember, sine is SOA. So I'm going to get my opposite, which is 1. And my hypotenuse, which is square root of 10. But I can't have a square root in the denominator, so I'm going to multiply top and bottom by square root of 10 and get square root of 10 on top and then 10 on the denominator. And so I'll just leave my answer like this. So this is my sine value. For cosine, I would have, in this case, my adjacent, which is 3, over the square root of 10. So for cosine, it's SOCA, which is the A is the adjacent, and H here is the hypotenuse. So my adjacent was 3, and my hypotenuse was square root of 10. Now, I don't like square roots in the bottom, so we're going to try to rationalize it by multiplying the top and bottom by a square root of 10. So that gives me 3 square root of 10 over 10 in the bottom. And I can't reduce 3 and 10, so I'll keep it the way it is. For tangent, this is going to be opposite over adjacent, so this is 1 over 3. And I think that is it for that piece. All right, we're going to move on to cosecant. So for cosecant, it's the opposite of sine. So if I started off with 1 over 10, for cosecant, that's going to be the flip. So it's going to be the square root of 10 over 1. Notice how I took this beginning value instead of this end value. It doesn't really matter, but it's easier to work with the beginning value, because notice that if I were to use this and I were to flip it, that means I would have a root in the bottom and I would have to try to rationalize it. So I'd rather use the beginning part and flip it. So I have square root of 10 over 1. And that 1 is kind of redundant, because 1 divided by anything is just itself. So this is just really square root of 10 as my cosecant. For my secant, it would be 3 over square root of 10 flipped. It's a reciprocal of that. So square root of 10 over 3. And I can't reduce this, so that is it. And that's it for this video. I hope you found it helpful. If you have any questions, feel free to email me or ask in class. Bye, guys.